What's up guys, Kinger's Garage, Kinger here. Today, different style of vid. This is a 101 series vid where I've done a bunch of research on EV and EV powering and drivetrain, and I just wanted to share with you some of my learnings because if you're like me and you like to go fast, you're drawn to the EV instant torque, right? That's the advantage of an electric motor over gas, and I'm trying to figure out how to put it into a build. That's what this video is. Does it make sense for you? What factors you want to consider? I've done months and months of research off and on, little bits and pieces here, and I've tried to make this a very concise video about what you would do when planning your own build. Let's go. All right, turning to the whiteboard. The most important law in all of this is voltage times current equals current times resistance. This is known as Ohm's law, okay? So this is a huge law to learn in any electrical system, and it applies here. Furthermore, power expressed in watts is equal to current times voltage, okay? We're looking to go fast. We want a big amount of power. So what do we look at? Big volts, big current. What car is the best at this right now? Plaid, baby. Let's look at a Tesla Plaid. We all know they're sick fast. What makes them tick? The Plaid horsepower has 1,020 horsepower. This is kind of a weird figure. It's like a mechanical figure that is used to convert to kilowatts or watts. So 1,020 horsepower converts to 760 kilowatts, which equals 760,000 watts. That's a big number, all right? Let's find out how much current a Plaid uses. This is I, so we can redo our formula here and solve for I. So we have 760,000 watts divided by 400 volts is what the Tesla system is. That means it draws 1,900 amps. This is insane. So kill you instantly if you were to absorb this. That creates a lot of heat, right? A lot of heat. The next big question then is, what is this discharge C rating? To support that many amps, you need a battery, and a massive battery, and a very well-cooled battery. So you come down here to your C rating, discharge, and the C rating is to how long it takes to discharge that battery. 1 hour equals 1 C. So if that battery goes dead in 1 hour at full discharge, that's a 1 C. The Tesla Plaid, they don't list this in their spec. You got to try to convert some formulas, but I've come up with about 10 C. That is incredible performance discharge rate out of a battery. So then we ask ourselves, what helps this C rating? Well, parallel cells. So remember, these batteries that Tesla has is made up of hundreds of individual 3.6 volt cells. And when you wire them in parallel, you can increase the C versus series wiring. So here's a parallel, and parallel is just plus to plus, minus to minus, okay? Series is plus to minus, minus to plus. So kind of like you wrote it, it runs in series. The current's going to go from minus to positive in kind of a loop like that, where parallel goes 2 times. And as you stack parallel, you don't ever increase the voltage. So if this was 70 volts and this was 70 volts, the output out here with an ohm meter is going to be 70 volts. If this was 70 volts and this was 70 volts, the output is you add them up. So 70 plus 70, you're gonna have 140 volts. So that's part of the conundrum, is this is good for discharge, but bad for volts. This is good for volts, but bad for discharge. Herein lies the conundrum. It's the motor versus the battery voltage and what you're trying to get for power. So when we zoom out, I got 3 scenarios here, my little sine wave in between. Let's start with the first one. 100 volt net gain. These net gain motors are awesome. They're 173 foot-pounds. They only need 100 volts. So you could theoretically get by with about a 100-pound battery. Now, battery sizing is a whole video in and of itself, but between series and parallel wiring, you can create how long the battery will last. I'm just looking at the bare minimums to get the thing to turn. Maybe say you use like a 100 volt net gain motor with that extra 173 foot-pounds as like a nitrous. It's on an axle that isn't driven in your car, and you just use it for 10 seconds or less. you can buy with a battery for about 100 pounds. That's really, really good, but it's not supercar fast. If you step up to a larger voltage, like a net gain 144 they just came out with, this was heralded as a really big advancement, you get the same foot-pounds of torque. I put a plus because I think that it actually would peak a little higher and hold it for a little longer than the 96 volt. You get less amps, but you're gonna need a battery weight about 200 to 300 pounds to support 144 volts. And again, not all in series, you need some parallel to get some discharge to be able to support these amps. And then a big one that I've been pondering is this Tesla swap. We all know Tesla is awesome and fast. I'm talking about the Model S motor here, not the Plaid, but they run on 400 volts. The large drive unit makes about 180 foot-pounds, 660 Newton meters. And if you do the math, like I showed before, that's about a 1200 amp draw. All of that is doable, right? So what do you want to do? Do you want a little battery, a medium battery, or this is going to take a monster battery? So my conundrum is, how much weight do you add to the car versus how many volts are you getting versus how much capacity are you getting versus what do you want to do with it? So for me, I'm in the market of trying to figure out a hybrid. Use some sort of performance driven axle that isn't normally driven in a car where I can get this, but I need to size the battery as low as possible because I don't want all the extra weight because I have a hybrid motor in the rear, let's say, or a gas, I should say. And this is the conundrum. But there's one last component to this that can help some of these. Let's get to that right now. The last thing, gearing. You always have to consider gearing. And gearing, if you remember, or if you don't know, is a torque multiplier. You simply take your torque times whatever gear ratio you give it. So in the case of this net gain motor, let's just say we hook it to a 10-to-1 gearbox. That's going to produce 1,730 foot-pounds of torque. Amazing, right? That would be a massively fast whatever you put it in. But then here comes the next sort of limiting factor. How many RPM will it spin? Well, the net gain is only good to about 8,000. The Tesla is good to 16,000. So here's where a lot of innovation for the Tesla starts to pan out. And you look at the Plaid and they talk about carbon fiber rotors and things. They're up in this RPM. Why? For max speed. Max speed is a factor of motor RPM gear ratio. So let's take some examples. So here, let's take an 8,000 RPM motor. We give it a 10-to-1 gear reduction with a 26-inch tire. You're gonna have a top speed of 61 miles an hour. Now, to get that number, go to any online gearing calculator, put in your gear ratio as like your final drive, and under the transmission gear, just put 1, because it's a multiplication thing, so it'll just multiply out, right? And that's how I get these. Take that same scenario, but with a Tesla 16,000, they use a 9.73 to 1 gear reduction built into the case. Net gain has nothing built in. Tesla has it built in. They use a bigger tire, and look what they get, 141 miles an hour. It's kind of a top speed. The Plaid does things even a little bit more extreme, higher speeds, gearing, tires, and that's where you're seeing the over 200 miles an hour out of the Plaid. So let's summarize all of this. Okay, I hope that helps. In summary, what we're looking at here is, how do you want to use this? Are you trying to create an EV only? That's a different probably use case. And for me, I don't find it worth the time. I can go buy a Model 3, I can go buy any EV, anything for less money than you're going to have converting something. Now I get it, you want to make something cool like an older car or some EV, that might be okay. And I would definitely only do a Tesla swap in my case. If you do anything lower and you're gonna need to hook it to a transmission, so hook it to, a 5-speed or whatever, then you get some gear ratios and you get some things for that EV to give it some more practical use, higher speeds, more torque down low, et cetera, et cetera, et cetera. That's what a transmission is designed to do. So that's what you'd have to do with a net gain motor. So EV with a net gain or 100 volt, low battery pack weight, low cooling needs, all that, you're gonna build a car that's peppy, feels more like a go-kart. You don't have to wait for it to rev out like a gas, and it would be fun, but it's not supercar, and it's not really worth my time, but it might be worth yours. Do you. Tesla, on the other hand, big difference. If you're going to use that motor, that's the highest power motor you can get. I haven't been able to find any that are more powerful, but then you got to factor in the weight of that battery. A Tesla Plaid battery weighs 1,200 pounds. So the best use case I've seen for that was where they swapped everything into like a Cobra, and it made it 3,300 pounds. The thing is lightning fast, and they used the Tesla battery in there, the entire battery. But again, you got to have cooling, and you got to have aftermarket controllers, which I didn't touch on. But if you do look around, you can get, there's a couple companies now, EV Controls is one, and a couple others where they're actually making controllers to control the Tesla Plaid setup. And when I'm thinking I want something faster than, say, my 700 horsepower RX-7 that's gas, I need something faster than that. So I'm not going to look at anything lower end. I'm going to go towards the top end. So that's really the conundrum with EVs, is you've got this heavy chunk of battery. Once technology figures out a way to have, say, a Tesla Plaid battery go from 1,200 pounds to 300 pounds, lights out. The EV all the way for performance, you know. And but until then, I'm stuck kind of in between the conundrum. Do I throw a 100-volt unit in with a low battery, give myself a 173 foot-pound, kind of equivalent to like a 7,500 shot of nitrous, but it's, you know, recharges, maybe it goes 5 miles on EV, you know, I don't know. You decide. What would you do with it? Tell me about your build in the comments. Hope this helps. Take care. Peace.